Hello, today we're going to present an empirical study on the effects of extract method refactoring. This work investigates whether applying extract method leads to measurable improvements in internal software quality, and we used real open source Java projects. I'll briefly walk you through the objectives, hypothesis, methodology, data, results, and finally the conclusions. So the main objective of the study is to evaluate the impact of extract method refactoring on internal software quality. Specifically, we focus on three key attributes: code size, coupling, and cohesion. We compare matrices values before and after refactoring to determine whether extract method leads to measurable improvements in open source Java projects. To structure the experiment, we followed the goal question matrix approach. Our goal is to analyze the effect of extract method on internal quality. The goal is translated then into questions about coupling, cohesion, and code size, and maintainability, which are then measured using well-established software matrices like CBO, LCOM, and the size of code, and so on. So our main hypothesis is that applying extract method refactoring reduces code size, decreases coupling, improves cohesion, and enhances maintainability, while preserving program behavior. The null hypothesis assumes that extract method has no significant impact on these quality attributes. We conducted a controlled before and after experiment. First, we selected 3 open source Java projects. We detected long method and code clone smells using static analysis, collected baseline matrices, and then applied extract method refactoring, and then remeasured the same matrices to evaluate changes. The data consist of Java source code extracted from mutual open source projects hosted on GitHub. The analysis focused only on classes and methods flagged with code smells using the tool that we used before. All projects were analyzed using the same tool, configuration, and granularity to ensure consistency and fairness. We selected 3 projects from different domains: workflow orchestration, scientific computing, and general purpose utilities. This selection provides diversity in size and functionality while keeping the language and refactoring technique consistent.
Let's now move to the result. Starting with cohesion, using the normalized cohesion matrix LCOM star, we observed that cohesion generally improved after refactoring. The improvement was especially noticeable in classes affected by long method code smells, while classes with already high cohesion showed only marginal changes. When examining coupling, a different pattern appears. In most cases, CPO values remained stable before and after refactoring. Only minor changes were observed, indicating that extract method was mostly applied through intra-class delegation without introducing new dependencies. Regarding code size, class-level line of code often increased slightly after refactoring. Now, this is very expected since extract method introduced a helper method, even though individual long methods became shorter at method level. Bringing these results together, we observe that extract method has limited impact when applied to very small code clones, such as a short getter method. However, for long code smells, refactoring led to a more noticeable improvement in cohesion. Normalized cohesion matrix provided a clearer insight than raw LCOM, while coupling remained stable and class size increased slightly. Before concluding, it is important to acknowledge some limitation. Refactoring applied manually may introduce human error. In addition, the study relies on a limited set of matrices and was conducted on a relatively small number of open Java projects, which may affect generalization. To conclude, extract method refactoring improved cohesion, particularly in classes affected by long method code smells. These improvements were accompanied by a largely stable coupling, indicating no significant increase in dependencies. Although line of code did not decrease a lot, long methods were reduced at method level. Overall, the results support the alternative hypothesis, and the null hypothesis is rejected.